adding and subtracting with decimals. So here's the procedure that we would probably use most times. So say we had this addition problem. 9 and 7/10 plus 9 and 7/10 plus 9 and 3/10 plus 9 and 45/100. So we want to find that sum. Let's first estimate to see about how much that might be. So let's just let's round it to the nearest whole number. So 9.7 is kind of close to 10. 9.7 is close to 10. 9.3 is close to 9. And 9.45 is close to 9. So if we estimate that 10 plus 10 plus 9 plus 9, we get 38. And I'm just going to mark that as my estimate. Okay. So now we're going to actually add them together. So first what we will do is we will list them vertically, lining up the decimal points. So I'm going to write 9.7. 9.7, keeping the decimals lined up. Then I have 9.3, and then 9.45. Okay, so you can see that we have all of our decimal points lined up, but we notice on this last one, we have an extra digit. So we have 45/100, and these are all in the 10th position. So what we can do, and as we learned in a previous lesson, we can add placeholder zeros after the last digit. We can add as many as we want. And I'm just going to make these zeros dashed just so that you can see that they're not really there, but they're holding that place. Okay, you can do that if you want, or just write a 0 in. That's fine with me too. Now what we can do is add just like we would, pretending that this decimal point is there, and I'll show you what to do with it. So we have 0 plus 0 plus 0 plus 5. And I have 7 plus 7 is 14, plus 7 is 17, or plus 3 is 17, plus 4 is 21. So I have the 1, carry the 2. I'm going to move a decimal point down. Now I'm going to add the rest. So I have 9 plus 9 plus 9 plus 9 is 36, plus 2 is 38. So our actual sum is 38 and 15/100. As we can see, our estimate was pretty close. That means we probably got it right. So now what we are going to do is estimate or to evaluate expressions given a value for the variable. So I have an expression, 9 and 67/100 minus x. And I have that 3 times. We're going to do this problem 3 times with different values of x. So what we will do is we're going to do this subtraction problem, and we know that we have to write it vertically. 9.67, and then we are going to subtract what we have for x. 1 and 52/100, 1.52. We are going to write it underneath here, but we are going to keep the decimal points lined up. So I will write it like this. 1.52 or 1 and 52/100. Now I can do the subtraction just like I normally do. 7 minus 2 is 5. 6 minus 5 is 1. I'm going to keep the decimal point right where it should be. 9 minus 1 is 8. So the value of this expression for that value of x is 8 and 15/100. So let's do this problem again, but have a different value for x. We have 9.67, 9 and 67/100. We are subtracting x, and x is 3.8, 3 and 8/10. Okay. So we see that we don't have the same number of digits after the decimal point. We can add, and we should add, a placeholder 0. So now we can line things up nicely. 7 minus 0 is 7. 6 minus 8 we can't do. So we're going to borrow just like we normally do, even though we're going across that decimal place. 16 minus 8 is 8. Going to move the decimal down. 8 minus 3 is 5. So now we can see that 9.67 minus x, when we put in 3.8 for x, we get 5 and 87 hundredths. Let's do it one more time. I'm going to do this up over here so I don't have to bend down so much. 9.67, and we are going to subtract x, and x is 1 and 1,000. So 1.001. Now this looks really kind of confusing if at first you've never seen it. So there's nothing here, and you're subtracting a 1 from it. No, we can't do that, can we? Or can we? So we are going to put a placeholder 0 right there. Now we can do our subtraction like we normally do. But we can't subtract 1 from 0. We have to borrow. So now this becomes 10 minus 1, which is 9. 6 minus 0 is 6. 6 minus 0 is 6. We are going to transfer the decimal point. Then 9 minus 1 is 8. So when we substitute in 1 and 1,000 for x, we get the answer 8 and 669 thousandths.